Everyone, hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft and I'm also an educator at Level. Now today what we are going to do is we are going to talk about, after taking an introduction about DBMS, we'll talk about a few advantages and disadvantages about database management systems and the components which actually make up the database management system. Okay, so first let's start with the advantages, right? So the first advantage of using database management systems is the segregation of application program, right? You have an application program, you have a set of data that you want to store, right? And based on the application program, you can segregate the data, right? There's a good level of segregation that database management systems basically provide. The second is minimal data duplicacy or data redundancy, right? The data is not redundant, right? You can keep the data, you can keep the redundancy as minimum as possible using a functionality which is known as normalization, right? So you don't have to store repetitive and unnecessary data. Third is easy retrieval of data. Now, we just don't want to store the information in an effective way. We also want to make sure that even if I do want to retrieve and take a look at very large set of data, it's quite easy to do that, right? Because querying and inserting both are very common and bulky operations, right? So you want to make sure that your query language is very, very effective and it helps you to do all of these operations. So query languages are very, I would say, good in these purposes. Fourth point is reduced development time and maintenance needed. So these days, database management systems are developed in such a wonderful way and in such a optimized way that the maintenance time for these databases is actually very low, right? They do not require a lot of maintenance, right? Once you start using it using minimal maintenance, right, you're able to keep your uptime very good and the downtime is very as low as possible, and the time to develop these systems is also becoming very fast these days. So it's becoming very quick to make these databases. Another point is with cloud data centers, we now have database management systems capable of storing almost infinite data. So earlier what happened was you have your information that you want to store, right? But your information is actually being stored somewhere else, correct? In big data centers, right? Which have big machines. You remember, like I think recently, I think GitHub, I think introduced the idea that they are making their data centers in very far secluded areas. I think it was Antarctica or somewhere, where they are creating new data centers to store all your information, right? Even companies like Google, Microsoft, they have big data centers which are storing all the information. But what happened was, with the evident of doubt cloud data centers, right, that means everything is stored in the cloud, it became actually very easy, right, to store infinite amount of data. So we are not limited or dependent on hardwares at all, and we can store as much information we want. So there's no limit, there's for time no limit on how much data you can store. You remember, you can go to Google Cloud, right? You can go to Drive and you can store as many files and as much data you want based on the subscription you've bought. So that's one another capability we have. Apart from that, there's the opportunity for seamlessly integrating your database management systems into the application programming language, which makes it easier to add a database to almost any application or website. Okay, so by that, what I mean is, let's say you are making a website. Okay, let's take a simple example. There's an e-commerce website on Amazon and the entire code, let's say, is written in Java. Okay, and all the orders that you place, all the catalog of the items that we have, all of it is in the database. Right now, let's say I go to the website and I basically search TVs. Okay, so I basically want to see and buy a TV. So Amazon as a website will go and fetch maybe a table called products, right? And in that there might be TV, and it will fetch all the TV options that we have available. So now this is the job of your application code to do that. Now database management systems are organized in such a way that even if you've written Java code, right, you using different ORM mappers and other functionalities which are available, it is very easy to fetch all the information. Similarly, let's say I have a project which is written on Ruby on Rails. Okay. So almost with every programming language, there are ways of creating seamless integration, okay, of the database management systems with your application programming language, right? So with the progress that these database management systems are doing, it's actually very easy to integrate your database with almost any application programming language that you are using. So that's why you want to keep your database management systems compatible, right? What if Oracle is system software comes and say that we are only compatible with Java? So that limits their use case, right? They want to make it compatible. They want to be used by almost every programming language. So that functionality is also available these days. Okay. Apart from that, there are a few disadvantages also which comes with when you use database management systems. So in the start, understanding database management systems for beginners, it's a little bit complex, right? So the complexity increases as the complexity of your data also increases, right? If you have a very complex data, there are very complex relationships with your data, then it's a little difficult to manage the database management systems as well. Okay. The second disadvantage is, except for MySQL, which is open source, licensed database management system softwares are generally costly. So if I go back a little bit, and if you remember, if we saw over here, some of these softwares, popular software that we use these days, or in all of these, the first one, which is the MySQL, is actually the one which is available for free and it is open source. But apart from that, all the other ones are licensed, where you have to pay a subscription amount every month in order to avail these services for these softwares. Okay, so MySQL is open one. We actually will be using MySQL only for getting a hands-on practice on database management systems. But remember, that's the only one that is free. Apart from that, all of them basically are licensed. That means you have to pay an amount to be able to use those, and those are generally costly. Big organizations can afford that because they have the relevant, I would say, resources and money, and they do want to make sure that the data is very secure. But in the end, you have to take the call that these are very expensive as well. Okay, so using database management system software, it's not a very cost-friendly option. Again, it also has disadvantage and advantages. Some of you might argue that, why don't we use just MySQL if it's open source, right? The thing is that the softwares which are open source, they are prone to bug, and there's not a dedicated customer service, right? So you can use MySQL because it's free, and that's very good option as well. But also remember that you do not get I would say dedicated customer care. There are a lot of bugs sometimes that comes, right, and they're not taken up very I would say quite frequently. Whereas the licensed ones, they are costly, but they provide you dedicated customer service. There's an option to call the customer care and resolve any issues that you want, right? And with that, they are more, I would say, organized also, and in case there are any problems, they're more quick to be taken up as well, because there is like a dedicated set of people who are working on these licensed softwares. Whereas for MySQL, it's open source, so anyone can come and contribute. So that's one disadvantage of being expensive. And the third is that they're very large in size. So if you have very small amount of data, right, and then it might not be very beneficial to use database management system softwares, because they take up a lot of space on your systems, right? So you also always have to take a collaborative call. So it's complex, it's a little complex, it's expensive, and the space they take up is really a big. Okay, so those basically make up for the disadvantages of using database management systems. Next, we are going to move and talk about some of the important components of database management systems. Now, there are a major 5 components which actually make up the entire DBMS softwares. Okay, the first is going to be hardware, the second is going to be software, the third is going to be data, the fourth is going to be procedure, and the 5 is going to be database access language. And now we'll take a deep dive and understand how all of them work. Okay, so here we'll first have a simple diagram to see how they all fit together, right? How all of them are basically connected with each other, and how by being connected with each other, they form a database management system. So we have the hardware, right, which is right in the middle. Then we have a overlying software layer on it, right? Because on top of hardware, we are writing the software for database management systems, right? We have a user, right? And for the user to access the data, like I was talking about, we have a database access language, or also known as a query language over here. Okay, so we have a software, we have a hardware, right? We have procedures, which we will talk about, and we have a database access language over here. Okay, now this is just a high level overview, right? We are going to now go deep into detail about all of these aspects one by one, and take a detailed discussion about what do they all do and what component takes care of what part of the database management systems. Okay, so let's take a look. So first we'll talk about hardware. So when we say hardware, we mean computer, we mean hard disk, we mean input output channels for data, and any other physical component involved before any data is successfully stored into the memory. Okay, so hardware, like a typical word hardware is mean over here. That means when we run Oracle or MySQL as the softwares on our personal computer, then our computer's hard disk, our keyboard, right, using which we type in all the commands, right, our computer's RAM, ROM, all become a part of the DBMS hardware, right? So now you are using a database management system software, okay? But to access or to do queries on the database, you will use your keyboard, right? The software, you have installed that software, so it's going to take up some part of your computer memory, right? You are going to store some part of it in your computer's hard disk as well, right? So all of these becomes DBMS hardwares, okay? Any physical component which is involved in the working, right, of the database management system software basically makes up the hardware for it, okay? Like I'm using keyboard, so I have to write my queries using keyboard. So keyboard becomes a hardware for DBMS, right? If I'm installing the software, it's going to take up some of my computer memory. So the RAM and the ROM basically becomes part of computer hardware. So that is what we mean when we use the word hardware over here. Then we talk about DBMS software. Okay, now this is the main component, okay, as this is the thing that is actually controlling everything. Okay, the DBMS software is more like a wrapper around the physical database. If you would have used a physical database, right, you would have just used a hard disk, right? Now on top of the hard disk, you made a software, you applied a wrapper over it, you made a software which helps you to access the information, right? Software is nothing but like that. Okay, it's more or less like a wrapper around the physical database, which provides us easy to use interface to store, access and update data. Now you could have used directly the hardware also, right? Magnetic tapes, drives, right? DVDs to basically store your information. That is nothing but a physical database, right? But it's very difficult to access the information using that physical database, right? It's very difficult to store, remove, update the data. So what did you do was you wrote a wrapper around it, okay? You made a software around it, and that software is interacting with the physical database to basically make sure that you have access to everything. And the software is designed in such a beautiful way that it's very easy to access the information. The tools designed are in a very user-friendly way. So that is why here in the image also you will see that software is basically like a wrapper on top of hardware. Okay, so that's how it basically works. Next is that the DBMS software is capable of understanding the database access language and interpret it into actual database commands to execute them in the database. Let me show you how it works. So this is your database, okay? This is where you are storing all the information, and this is you as a user, right? Now you query the database, right? You want to, let's say, see how many students are in the class who have an age above 10. Okay, so you will definitely you want to query the database, so you will be using the query language, right, for the database. But database does not understand the language. The software which is used and written on top of the database basically understands the query language. Okay, it understands the query language. Your database does not understand the query language. Your software understands it and converts the query in such a way that the database basically understands it and then gives the required results. Okay, so always remember, your database do not understand any kind of language, because they are just a physical way of storing information. Language is like obsolete for them, right? User knows or learns a language, it communicates, it requests with like using the query. The software that is written on top of the physical database understands the query and converts it in a way that the database can understand and interpret and execute the information which is actually requested for. So software is like the heart of this entire DBMS, right? DBMS system. It actually needs to take care of a lot of things, and it has to become like a above layer for the entire system to work very smoothly. Okay. The next thing is obviously the data, right? We are working with data. The whole shebang that we are doing here is because of data. So data is that resource for which actually we design databases, correct? The motive behind the creation of database is to store and utilize the data in a very effective way. We have the data earlier also, we have the data now also. DBMS basically got introduced to so that everything happens in a very optimized and a smooth and a faster way. Now in a typical database, the user saves data is present and metadata is also stored. Okay, let's say I have a students table where I am basically storing the data for all the students. But what information I am storing in the table, right? The data about the data is about kind of like a metadata. For example, the metadata for the students table is like I am storing information about the students for a particular class. So that's metadata. Some information that tells what kind of data is stored in the database is known as metadata. Okay, like it says here in the definition also, metadata is data about the data. Some information, some 2 lines about what information are you storing. This is information that is stored by the database management system to better understand the data stored in it. So if I'm storing a student's table, that's just a table, that's just some information. But if I also store the metadata saying that, you know, this data is about the information of a students for, let's say, class 6. Now your system understands the data a little bit better now because they have some context about what information is there in it. Okay. For example, when I store my name in a database, the DBMS will store the name, will store when the name was stored in the database, what is the size of the name, it is stored as a related data to some other data, or is it independent, and all this information is metadata itself. Okay, this is more like a typical example in terms of DBMS, right? If you see over here in this, right, now here the students, I would say, table and the teachers table were related to each other, because in the students table I had a column for subject, okay, 2,3. So I know that here this information for all the subject ID is basically used in other tables as well, correct? So database management systems need to understand this, right? That all this is being used in other tables as well, and because of that the teachers table and the subject table is related to each other. So using the metadata, right, DBMS basically tries to draw relationship between the different information that you have stored. Okay, so that is why it says that when you store, let's say, a name in database, right, it tries to understand, right, where it is stored, right, what is the size of the name, right, what are the number of characters, is it related to some other data, is this information being used somewhere else as well, or is it just independent data lying in the database? All this information is basically metadata. So the third component is data, right, the actual information which we store in the databases. The fourth is procedure. Procedure basically refers to general instructions to use a database management system, right? This includes procedure to set up and install a database management systems, to log in and log out of a database management system software, to manage databases, to take backups, generating reports, etc. So this happens more like at the enterprise level. So when you're working in a company, right, you have some, let's say, database management system you are using, right? So you want to be able to fully and completely and correctly install the software, right? So there are a particular steps, there are a particular procedure, right, and tasks that you have to perform to install a database management system, right? There are particular steps defined to log out and log in into the software based on your user access, right? You want to make sure that you take regular backup of the data, because you don't want it to be a single point of failure. Let's say you are storing all your information in a computer and the computer gets corrupted, all your information gets lost as well. So you don't want that to happen. You want to take regular backups of the data so that you have everything available in a secondary place as well. So there are steps you need to take care of, or you need to perform to take backups as well, right? There are ways where you can analyze the data and generate, let's say, monthly reports, as in how many new lines or how many new information got added in the database, what all information got removed, right? What is the percentage of increase in data? All these ways are usually used to generate reports. So there are particular ways and steps to perform for that as well. So procedure is basically general instructions you have present to do operations on the database management systems, install management systems, right, and set up those databases. Okay, so all these steps, right, are collated and termed as procedures. Next, we talk about database access language, which is what we were talking about earlier as well. This language, or this database access language, is a language designed to write commands to access, insert, update, and delete any data stored in a database. Because we as user cannot directly access the database, we have to write a query. That query is understood by the software, and that software, right, basically understands that language and converts it in a way and uses it to basically access the databases. So a user can write commands in the database access language, submit it to the database management system for execution, which is then translated and executed by the DBMS. Now users can create new databases, they can create new tables, they can insert data, they can fetch the data which is already stored, they can update the data, they can delete the data using the access language. Okay, so us as a user and the DBMS, there's like a way of communicating everything that happens using DBMS, or database access language. Okay, so these are all the 5 components that we talked about. So let's quickly summarize what all we covered in this video today. So first, we talked about a few advantages of using database management systems, right? There is very minimal redundancy, right? They're very quick to use as well. There are a lot of options available, right? You don't have to do a lot of maintenance for these database management systems, right? You can store infinite amount of data these days, and you can integrate your database with any programming language or any application you want, which makes it very easier to use them. But the disadvantage includes that they are quite complex, that they are expensive, and they take up a lot of space. That being the disadvantages. Then we talked about the few components of the databases. First is the hardware over here, right? Hardware is nothing but anything that is used by the database management system. Keyboard, you write your command, this is a hardware. Your database management software is stored and it takes up computer memory, that's also a hardware. Next, we talked about software, right? Software is like a wrapper written on top of hardware so that it understands all the commands that you write, right? And basically executes those commands and fetch the required results for you. So it's like a wrapper which is written on top of a physical hardware, okay? And it is capable of, I would say, executing queries, and it also basically provides a good interface for you to access the databases. Then we talked about data. Data is like everything around which DBMS is revolving around, right? Data is basically something that you require and what you need to store in the database management systems, right? And data about data is metadata, okay? when you have some data and you store some more information about that data, about how that data is related to other data, is it independent, right? Or is it, what information do we want to derive with it? How does DBMS basically understands that data? Is it metadata? Then we talked about procedures, right? Procedures is nothing but, the steps or the instructions that helps you to tell how do you set up a data, how do you install a database management systems, right? How can you perform queries, how can you generate reports, how can you take backups? And the last is database access language. That language is nothing but how you as a user breaks the wall between the database management systems and communicate your queries, like how do you want to insert, fetch, delete, manage, update, anything that you want to do. You have to convert it into a relevant language, you have to convert it into a relevant query, and then only you will be able to get the required results. So all these basically form the components. Okay, so I hope this helps you to understand how it all works, and I was able to break down this entire component thing into small parts and help you relevantly understand the advantages as well as the disadvantages of using database management systems. Now in the next videos, we'll talk about what kind of users are available for the databases, right? And some other components related to that as well. So stay tuned, keep practicing, make sure you go through all the slides once again before you go to the next video, and I will meet you definitely in the next one. Thank you. Bye.